Good afternoon, everyone. I am Astha Lutari from MTech IT 4th Sem, and today we will discuss question number 4 of lab assignment 3. So, our question is derive formulas for algorithms for numerical quadrature and obtain trapezoidal Simpsons 1 by 3 Simpsons 3 by 8 rule and Vidal's rule from it. First part is Newton-Cotes formula and second is Gauss quadrature formula. To derive the formulas for algorithms for numerical quadrature, we begin with the general idea of numerical integration, estimating the definite integral of a function when an exact analytical solution is difficult or impossible. We approximate the integration a to b fx dx using a weighted sum of function values at specified points in the interval ab. The general formula is integration a to b fx dx is equals to summation I is equals to 0 up to n wif xi. This is called a quadrature rule where xi are the chosen nodes in AB, wi are the corresponding weights. Now let us derive some classical rules. First one is trapezoidal rule. Derivation: divide the interval AB into n subintervals of equal width h is equals to b minus a by n. Approximate fx using straight lines between points, that is linear interpolation between adjacent values. For a single subinterval x0 x1, integration x0 x1 fx0 dx is equals to h by 2 fx0 plus fx1. Composite trapezoidal rule is integration a to b fx dx is equals to h by 2 fx0 plus 2 summation I is equals to 1 n minus 1 fxi plus fxn. Now the second rule is Simpson's 1 by 3 rule. Derivation: approximate fx by the quadratic second degree polynomial through three equally spaced points. Requires even numbers of intervals. N is equals to 2m, h is equals to b minus a by m. For the interval x0 x2 with midpoint x1, integration x0 to x2 fx dx is equals to h by 3 fx0 plus 4 fx1 plus fx2. Composite Simpson's 1 by 3 rule, integration a to b fx dx is equals to h by 3 fx0 plus 4 integration or die fxi plus 2 integration even I not equal to 0 and fixi plus fxn. The next rule is Simpson's 3 by 8 rule. Use a cubic polynomial through 4 equally spaced points. Subdivide the interval into multiple of 3, that is n is equals to 3m. For x0 and x3, integration x0 to x3 fx dx is equals to 3h by 8 fx0 plus 3 fx1 plus 3 fx2 plus fx3. Composite Simpson's 3 by 8 rule. Apply over each block of 3 intervals. Integration a to b fx dx is equals to 3h by 8 fx0 plus 3 in summation I is equals to 1 I mod 3 not equal to 0 n minus 1 fxi plus 2 integration I is equals to 3 I mod 3 is equals to 0 up to n minus 3 fxi plus fxn. And the last rule is Vidal's rule. Based on 6 degree polynomial interpolation using through 7 points, requires number of subintervals to be a multiple of 6, that is 7 points. For the interval x0 to x6 with h is equals to b minus a by 6, integration x0 to x6 fx dx is equals to 3h by 10 fx0 plus 5 fx1 plus fx2 plus 6 fx3 plus fx4 plus 5 fx5 plus fx6. This rule gives the very accurate estimate but is less commonly used due to its complex coefficient pattern and requirement of 7 points. Thank you for listening.